Good Tuesday, everybody. To you income 603/gov 603. Welcome to week. Boom, bam, 13. 13. 3 more weeks to go, and then you are across the finish line. Okay, how's everybody doing? Let's start this video off correctly. Craving wilderness as I am. It's strange to someone that ends up in academia prefers to be outside most of the time, as I do. What are you going to do? I think I got this cup at the Denver Museum of Natural History, if I recall. I could look on the bottom. Yep, Denver Museum of Natural History. All right, but enough about me. Let's talk about you. Okay, so this week we're going to shift gears just a teeny weeny little bit, and we're going to start looking at qualitative research methods. Okay, we've been looking a lot at quantitative research methods, and there's a reason for that. Especially in the political sciences, most of the research that you see falls into that category of quantitative. It's numbers, it's quick, it's polls, it's surveys. But there's still room for qualitative research. Take the election, for example, which we just had. Okay. I mean, this is an interesting case in point for what we've been talking about. I think one of the central questions that came out of the election, or at least should be asked in relationship to the election, was how was it that the pollsters got things so wrong? Now, there were some who did not. There are some polling individuals and organizations that I spend time with, and I tell you this not as an I told you so, because I didn't tell you so, but just sort of an FYI. I had written down, I live in a cul-de-sac. I live in a neighborhood in which there's some different political opinions, which is fine. We all get along, and we go out and we go out. I mean, we sit outside together, and sometimes we'll have a bonfire. It's a cul-de-sac, so we can put a little, one of those outdoor burners, basically a big copper kettle, and we sit around and we talk. And there are differing political opinions. And I said, I'm going to make a prediction for the election, and I predicted that Donald Trump will win, and I suspect that he'll get over 300 electoral votes, both of which occurred. Now, the reason that I was able to make that prediction with some accuracy was I was following, there are a couple of pollsters and polling organizations that go about their quantitative methodology in a more reliable way than most of the others. And so the question that pops up, however you voted and however you feel about the election, is why was it that a number of pollsters nationally and locally were so wrong? If you look at the sort of the central tendency, if you average all the polls together, the pollsters together, and you get this bell curve, look at the central tendency. Their predictions were that this election was a coin flip, that it was within the margin of error, that is, that smaller number of the confidence interval. And their confidence interval, by the way, is 97, which, methodologically, when you see things associated with human behavior that have a confidence interval as high as 97%, that in itself should be a red flag, because human behavior is very, very difficult. Even when you have all the information in the world, it's difficult to predict. All right. But nonetheless, that the polls were within the margin of error, plus 1 or 2% for Vice President Harris, plus 1 or 2% for former President Trump, and going into the election. And then there was the Iowa Register poll that had Kamala up by 4, which is outside of the confidence interval, the margin of error of that 3% in the state of Iowa. And as it turned out, it wasn't even close. It wasn't close at all by way of electoral victories. Now, this is not the most outstanding thumping, but it was a thumping. I mean, Reagan against Mondale was a severe thumping. Nixon against McGovern, was it? I think that was another thumping. But this was a solid win. This was not a win that fell in the margin of error for a confidence interval as high as 97%. And the question that should be being asked by people on all sides is why? Why did the polling, why was it so wrong? Well, that takes us back to our class. Remember how we started this semester with the discussion about researcher blind spots? Now, I don't mean in a malicious way with what I'm about to say, but researchers often lie to themselves by way of omission of data that they leave out. For example, now that you've done a couple of weeks, back a couple of weeks, you did a regression analysis and you did a t-test. And with that t-test, you're familiar with the p-value, which stands for probability. Okay. One of the common ways to, now this is something that's intentional. One of the common ways to manipulate outcome is to eliminate parts of the data until you get a p-value that you want. So imagine you were going to run a standard t-test like you did, okay, with the track, the 100-meter speed for top 100 women, top 100 men, okay. And you started to remove certain scores that were really fast on the men's side or really slow on the women's side, whichever. Okay. And then you ran the calculation again, and then you ran the calculation again. And then by removing those scores, and this is much easier to do when you have a really big database. So let's suppose that instead of, we looked at I took 20 from the top 100. Okay. But let's suppose that you entered in all 100 for both men and women. You entered in all the values. Okay. Then you don't like the p-value. You're like, well, no, there's got to be something going on here. The p-value is really, really low. Okay. And you go, no. So you start removing scores from one side and removing them from another, and then rerunning the regression and now the t-test and rerunning the t-test and rerunning the t-test until that p-value approaches 5%. That process is called p-hacking, and it goes on in statistics. Now, back to the election. So I don't believe that many, in fact, I don't believe that most pollsters deliberately manipulated their data in the sense that they removed stuff until they got the answer that they want. What I do know is that they did manipulate their data with the assumption that there was data that they weren't getting. And this is why the values that they had stated were so off from the result. What do I mean? All right. So starting, with the polls done by groups and or individuals that tended to lean left. Now, I'm not saying that pollsters, all pollsters that lean left wanted Vice President Harris to win. But if that's their political perspective, one of the things that they did, and you could see it in their data if you look at the raw data, whenever you see a poll, and most of what you get is just called descriptive statistics. They just count up and they say this percentage for this percentage for this. They're not doing any statistical tests. All right, so you should automatically be cautious about saying, well, that's what it means, because if you just count jelly beans in a jar, that doesn't tell you how the mixture of jelly beans that you counted got to where it is, or how one flavor affects another. So anyway, that they assumed, those that tended to lean left, they assumed that suburban women were underrepresented in their polling. And looking at the percentages, suburban women tend to vote more for the Democrat candidate And actually, as it turned out in the actual voting, tended to like about 70-30% vote for that candidate, in this case, Kamala Harris. So when they do a poll and they don't reach a sufficient number of the suburban, and this is just one example, this isn't the only thing that's done, they don't reach a sufficient number of suburban women, they compensate within their poll by adding in more women from the suburbs, or they will reduce the number of other respondents. So one relative to the other, the number of suburban women go up because they go, well, they're underrepresented in this poll, so we're going to fix that. Well, that makes an assumption about human behavior. That assumes that suburban women are going to get out to vote, and they're going to get out to vote for the candidate that tends to be on the left side of the political spectrum. Okay. Secondarily, one of the things that they missed, and this is the polls that got it wrong, there is a certain core of Americans, and this crosses all demographics in terms of race and economic status. And for lack of a better term, they fall into what I call the category of the screw you voter. They're angry at the status quo. They don't like government. They don't trust government. They don't like government institutions. And again, this crosses all kinds of racial barriers. And they don't talk to pollsters because in most instances, mistakenly, they see pollsters as government, and they don't want to give their information out, or they don't want to answer questions that they think is going to give information out. Now, everybody's free to have their own opinion. The reality of the matter is, if you spend any time online doing anything, your information is already out. The data miners, they're swimming around underneath your feet all the time, slurping up all kinds of information about you. So, by not answering pollsters, you're not keeping yourself a secret from anybody. That's just the reality of the nature of information exchange in the technical age we live in. Nonetheless, if you look at the last two elections that Donald Trump was in, you can see the pattern. In the first election in 2016, going into the final 3 days, he was about depending on the poll that you look at, 4 to 6 points behind Hillary Clinton. And he beat her narrowly by about 1.5%. Going into the 2020 election against then Vice President Joe Biden, he was down by anywhere from 8 to 10, depending on the poll that you looked at. And he narrowly lost by about 1.5 to 2 points. Going into this election in the last 3 days, it was neck and neck. So looking at the historical patterns of voters who don't talk to pollsters, and then they do talk when they go to the polls, I could see, using statistics, that this was going to come out the way it came out. But that takes us to this week's topic. One of the ways to find out why people do things is qualitative analysis. That is to sit down and just talk to them. Quantitative analysis is really good to tell you that something is going on. It's not as good to tell you why, especially when it comes to human emotion. All right. Now, so when you're looking at causal relationship between variables that are outside of human behavior, like, say, comorbidities to severe outcome within the system when you get COVID, that's great. Quantitative works really well for that. But if you want to know why it is that somebody voted the way they did, from whatever demographic you're looking at, the best way to find that out is to sit down and talk to them. And the blessing is the I'll say curse, but that's not what I mean. The opportunity is the labor in qualitative research, and that is to get to the why. You have to talk to a lot of people, and you have to just listen openly and record what they say. And then One of the ways to get down to the why are they behaving this way is to do something called a content analysis. And you look for specific words or phrases that are established, within the society that you're dealing with, as meaning whatever. I'm happy, I'm sad, I'm angry, I'm optimistic. Okay. So we're going to start learning about that this week. And next week, I'll actually give you an exercise in content analysis for qualitative research. Okay. Because they're both useful, especially in political science. But they're useful in different ways. Okay. So that's what's coming up. Let's take a look at what you did last week. Okay. And answer your questions, see if we can add anything to it. Okay. So last week we took another slight segue into the terminology and definitions within quantitative research. And these are terms, you've just got to have. I mean, by way of definition and understanding, you just got to have them both, because you'll see they pop up all the time in quantitative research pieces. Okay, question number 1. What is a dummy variable? How is it created? Why should a researcher use it? Either post an example in your research or link to an example. Okay, Damien, let's take a look at you. A dummy variable is what researchers use when they have multiple categorical variables. A dummy variable acts as an indicator instead to differentiate the variables. Okay, that's exactly right. But remember, what I need you to be able to do for yourselves, explain it to yourselves in plain English. And the classic example, and I think this is in your video, is let's say that you wanted to determine the fuel efficiency, or I think in the video it's the speed, the average speed of a truck. Okay. So all these cars go by and you're taking the speed, you get a little speed gun, beep, 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 beep. Okay. But you have trucks go by, minivans go by, sedans go by, compact cars go by, semi trucks go by, and you're just interested in trucks, like as in Ford F-150. And you have all of these different types of vehicles. Well, you're not interested in all of these different types of vehicles. You're just interested in trucks. So one of the ways that you can code the data is to assign the trucks a number, like, and it's binary, so it's 0 or 1 or 2. I mean, it really doesn't matter. Standard form is 0 or 1. So you say, anytime I see a truck go by, I'll write down a 1. Anytime I see anything that's not a truck, I'll write down a 0. The 0 is the dummy variable because it stands in. It doesn't mean it's stupid. It stands in for a whole bunch of other things that are not the thing you're interested in. Does that make sense? Right? And if it doesn't, please reach out to me. Okay, question number 2. What is a categorical variable? All right, this one is, this one and a continuous variable is actually really important. I'll say a little bit about the two of them in just a second. Okay, Amber. Categorical variables are variables you place in a group representing something. In research, they are turned into numbers for statistical analysis. Okay, good. Now remember, you got to be able to explain this to yourself in plain English. And if that makes sense to you as is, that's perfectly fine. Morgan, categorical variables work to represent the types of data which are divided into groups. These can be race, sex, age groups, even educational groups. The information is normally placed in a numerical manner. The information then is normally put into a data table which involves counting numbers of observations that fall into each group of 2 variables. Okay, yes. So categorical variables is a way to describe data. Remember what I said last week, that when you have data and you say this is categorical and this is continuous, it's not like saying this is chaps, this is lip balm and this is pen. Okay, these are 2 different forms of things. I can't use this lip balm like I use this pen. I can't use this pen like I use this lip balm. Okay, that's not what we're talking about. We're talking about how data is best categorized. Now, I don't mean that makes it a categorical variable, but whether it's a categorical or continuous variable It's how data is best categorized. All right, so question number 3, what is a continuous variable? Alyssa, right here, you on the top. Continuous variables are variables in the data that have meaningful order with consistent numerical intervals. Penn State Stat Course states that continuous variables have characteristics that vary and can take on any value and any value in between. Okay, that's true. But again, make sure you can explain this to yourself in just plain English. Lane, continuous variables are variables that can change and are typically in a range. Perfecto. For example, if we look at the temperature over the course of the day from 59 to 100 degrees, these variables are continuously changing, and there's always another variable between the two variables. Excellent. Okay. So what, I said I wanted to tell you a little bit about something that's really important, the difference between putting data into labeling data. Maybe that's a good way to put it. Labeling data as a categorical variable, labeling data as a continuous variable. Why is this important? Because there's some phenomenon that are best described as categorical. There's some that is best described as continuous. Okay, yeah, like what, you might be saying? Categorical data that's best described as categorical is data, happenings, any occurrence, okay, in which the exceptions to the categories, to the rules, are so small that they're statistically insignificant. All right, so that means if you ran a confidence interval of 95%, the exceptions to, like, the coin flip, okay, let's assume that there's nothing going on with this coin. This is not a trick coin, and we flipped it. We would expect 95% of the time it to land heads or tails, at least 95% or higher. So heads or tails would best be described as a category, that type of data. Okay. Continuous variable, on the other hand, are things that by their nature range along a data scale, okay, and are not easily put into categories because the changes, which is the exception, the changes are statistically significant. And I'm going to give you an example that's important, that has important applications to political science today. Okay, so we've just come out of the election. Now, one of the things that I thought was curious is now President-elect Trump had recorded a video back on January 31st of 2023 as sort of a, this is what I stand for. So it was then candidate Donald Trump. This is what I stand for, and if you elect me president, this is what I'm going to do. And he focused in specifically on gender and gender identity and use of facilities like bathrooms and participation in sports that's marked out for women, and men saying that they're women and participating in sports. And you can find that video. I won't post it here, but you can find it. That they re-released it, which I thought was really curious because it was an old video. It was posted in early 2023, but in the lead up to the campaign, it may have been prior to the vote or just after the vote, they re-released it. Okay, what does this have to do with categorical and continuous variable? At the heart of this debate, that is, of the gender identity debate, what's going on is there are social scientists who are trying to, I'm putting the quarterback over there, who are trying to change the designation of the data, that they are saying that sex, and this is, you might hear this phraseology, sex is not binary. It's not either male or female. So what they're saying is that the classification of the data type that is sex doesn't belong in the categorical variable section. I hate to say categorical variable category because that sounds redundant. It doesn't belong over with categorical variable. It is continuous, a continuous variable. Here's the problem with that from a statistical perspective. What distinguishes categorical from continuous variable is, remember that the exceptions to the categories are not statistically significant. Okay? So yes, it's true. There are, and this is a biological term, intersex people, people that when they are born, even if they have a clearly distinguished genetic sex, XX or XY chromosomes, when they're born, their testicles don't descend. They have poorly differentiated genitalia. Um, Even rarer are XXY chromosome configuration. Okay, those things happen, but they happen at such a small rate that they're not statistically significant to the two categories over here that are male and female. So you can't just move a data set from the categorical category over to the continuous because of a few exceptions. Now, feelings, on the other hand, those do belong in the continuous variable because they range all over the place. Okay, we don't experience emotion in a binary way. It's not like, oh, I'm either up or I'm down. I'm happy or I'm sad. I'm this or I'm that. There is a scale. And so those who are pushing back against those that argue that there's a large and a varied number of genders are saying no, because there are some very small exceptions to the categories, doesn't nullify placing this data as a categorical variable. And so you can't say, well, there are these small exceptions and therefore it's continuous. We don't know how many genders there could be. It's continuous. It could be hundreds. It could be thousands. And there are those that advocate that very position. So without getting into the biology and all of these other things, from a statistical perspective, from a descriptive perspective, the fundamental error is what's going on here is they're trying to move what is clearly categorical data over into continuous data. And it's just not, because the exceptions to the categories, in this case, 2, are so small as to be statistically insignificant. Now, someone might say, but wait a second, if someone says, well, my inner identity doesn't match my external biological sex, gender, isn't that the exception? No. That is an expression of feeling, which goes over into the continuous variable category. And by the way, in this discussion, I am in no way saying that someone doesn't struggle with feelings about a misalignment. In fact, the technical term is called gender dysphoria. That's got nothing to do with it. What we're talking about here is those that are advocating, pushing the idea that there are just genders beyond, counting. They're trying to move categorical data over into a continuous data category. And that it's a violation of the statistical rules by which we understand our physical universe. Namely, if there are small exceptions, statistically insignificant exceptions to the category, you don't move it out of the categorical variable. So another example is, you can say as a category, all right, humans have 10 fingers. That's a category. All right. Pigeons do not. Okay, that's a binary category. But what if somebody's born with less than 10 fingers or more than 10 fingers? Are they suddenly now not human? They could be pigeon? Well, no, because the instance of that is small enough that it's statistically insignificant to the number of humans that are born with the 10 fingers. Now, and then on the other side, you don't find pigeons with fingers. They have feathers. And I don't know of any instances in which pigeons were born with fingers and not feathers. So I don't know if there's any violation to that category. That's why understanding the difference is important to you right now in 2024. And that's what's going on is the incorrect labeling of one type of data, and I'm sorry to use this term, the misappropriation of a categorical variable into a continuous variable, and it just is not. All right, question number 4. Let's wrap this up. Look online and find an example of regression analysis with categorical variables, because normally regression analysis is done with continuous variables. Because look, by way of causation, all right, what you're looking for is as this moves along the categorical, the continuous spectrum, okay, so emotion, how well someone is or not, how many comorbidities they have or not. And you'll notice the researchers in that data set that we did, they looked at 4, but they could have looked at 10. They could have looked at 50. But what they found was there was a real significant statistical jump in the effect after just 2 comorbidities. All right, but they could have looked at a whole bunch. Okay. All right. So normally regression analysis is done with continuous variables. So I asked you to get out there and find an example in which it's done with categorical variables. This is called a chi-square test. Let's see, Damien. Let's see. Let's see. Let's take. I'm looking. I had an answer here marked. Robin, by the way, a nice chart that you posted. Okay. Charles, let's look at you. The example shown below from Zaontes illustrates how regression can use categorical and continuous variables to create a model that predicts income based on political party, gender, and age. On the left-hand side are the variables representing from typical data collection process. On the right hand, the researcher has transformed the categorical variables into dummy variables. Bam! Okay. One of the ways to handle continuous variables, if you want to do something like regression analysis, is turn them into a dummy variable. All right. So everything that is a truck gets this number. Everything that is not a truck gets a 0. Okay. Exactly right. Now, again, remember, I need you to be able to explain this to yourself in just plain English. Okay. That's, that if you don't get that, then you miss the point. Okay, half an hour is up. We are done. All right, everybody. Now remember to keep working on your final paper. All righty. And that's the 12th of November. Maybe in like next week, I'll poke remind you to start studying for the final exam, and it'll be drawn from the same material or in the same way. Important distinction as the midterm exam. All right, we're going to be drawing it from the discussion questions. All right, so make sure that you are familiar with them, and you'll be all good. All right, everybody, thank you so very, very much. I hope you have a blessed week. I think about you. I pray about you. And as always, I will see you on Canvas. Bye-bye.